Hello and welcome to the live broadcast of Rocket Lab's 5th Electron launch, the R3D2 mission for DARPA. We are currently sitting at T-minus 11 minutes from target liftoff. The weather is looking green and we are ready to launch this mission to orbit. My name is Max Muncy. I'm part of the mission operations team here at Rocket Lab, and I am coming to you live from Mission Control here in Auckland, and I'm so glad you could join us to watch yet another Electron launch. What you're looking at now is a live view of the Electron rocket on the pad at Rocket Lab's Launch Complex 1 on New Zealand's Mahia Peninsula. We've got microphones down there so you can hear the final stages of launch operations, and if you're lucky, you might be able to hear some of the local birds as well. Launch Complex 1 is the world's only private orbital launch site in operation. Operating our own launch site gives us an enormous amount of freedom and flexibility to launch frequently and on our customer schedules. This is important because launch frequency is key to providing better access to space for small satellites, and with Launch Complex 1, we can fly up to 120 missions each year from the same pad. Earlier we had confirmation in the final poll that we are go for launch. Today's mission is an exciting one, as it's our first mission for the Defense Advanced Research Projects Agency, or DARPA. This flight is a dedicated mission for the agency, which means one microsatellite weighing around 150 kilos is the sole payload on board. Electron was designed exactly for the size of this spacecraft. By offering a dedicated ride to orbit for satellites in this 100 to 150 kilo class, we can provide small spacecraft customers with frequent launch opportunities, scheduling freedom, and precise orbital insertion. The spacecraft onboard Electron today is called R3D2, and this stands for Radio Frequency Risk Reduction Deployment Demonstration. This mission intends to space qualify a prototype reflect array antenna to improve radio communications in small spacecraft. So we have a short video from DARPA which explains more about the payload and its mission.
R3D2 is the RF risk reduction deployment demonstration. And what we're doing on this mission primarily is demonstrating a new high compaction ratio deployable antenna. So an antenna has a lot of different uses for DoD. One example is communication. The antenna and the power you have in the satellite dictates what size of antenna you need on the ground to receive it. So the bigger the antenna you can have in space, the smaller the one can be on the ground. Fitting that very big antenna into a smaller satellite makes the satellite less expensive and allows us to leverage different types of launch vehicles that maybe we wouldn't be able to use for bigger satellites. So once it reaches orbit, the first thing we try to do is gain communication with the satellite. Once we've done that, we'll deploy our solar arrays, and then the small container on the top of the satellite is where the antenna is housed. So it has 4 different carbon fiber deployment mechanisms that will go out on each corner. And then it has a pantograph, which is a shape that kind of looks like an accordion, around the outside that will expand. And then we will begin to see how flat the antenna is. We'll do some assessments from the ground to see what it might be able to transmit. And what's really making the antenna work is the copper etchings on top of the kapton. So kapton looks a lot like cellophane you might have in an Easter basket. And so it's a great place to hold the copper, which is what is reflecting the energy. And it's just set into the kapton. And so when electromagnetic radiation hits the antenna, it acts like a parabola and focuses that energy instead of acting like a flat plate.
And there you have it. We are incredibly excited to have R3D2 aboard Electron today. The R3D2 spacecraft will mark the 25th satellite deployed to orbit by Rocket Lab. We had a busy year in 2018 with 3 orbital Electron launches, and those launches saw us deploying a variety of commercial and government payloads to orbit. We are in March already, so it feels good to be back in the pad for the first mission of 2019. Right now, R3D2 is scheduled to deploy from Electron's kick stage at around 53 minutes after liftoff. Due to the position of the spacecraft at the time of deployment, we won't have live video feeds, so we'll be ending today's webcast after separation of the kick stage. If you want to know how things are going, make sure you keep an eye on Rocket Lab's social media channels for confirmation of payload deployment. This year is going to be a busy one for Rocket Lab, building and launching rockets every month. Frequent launch has always been the goal here at Rocket Lab, and we spent much of the past year scaling our facilities to support rapid manufacture and launch. Currently, our team is building an Electron every 30 days to support this launch cadence. From day one, every aspect of Electron was designed for rapid manufacture, including the 3D printed Rutherford engines, the fully carbon composite rocket bodies, and even the payload integration system. Our customers have the freedom to integrate their satellites on-site at the launch complex or at our headquarters in Huntington Beach, California.
Stage power locks down and FTS powers on.
Thank you, Asio. FSO flight mission.
Go ahead.
I can confirm the FTS is on internal power. Check tone should be up continuously from now.
Copy.
Please enable the FTS failsafe and confirm.
Failsafe enabled. Confirmed.
FTS flight mission.
Go.
Confirm FTS is green and on internal power.
FTS is green and on internal power.
Thank you. Okay, all stations, this is flight on mission cord. From now on there should be no red flags on your LCCs.
Flight mission cord.
Go ahead.
RCO. Range is green, auto sequence armed.
Copy, thank you. FSO flight mission.
Flight safety is green.
Thank you. Avionics flight mission cord.
Flight avionics.
Please disable the HVAC heaters and confirm.
HVAC heaters are disabled.
And please disable the HVAC heater fans and confirm.
Heater fans are disabled.
LD flight mission cord.
Yes, flight.
I can confirm the vehicle's ready for flight.
Copy.
Now as we hit T-minus 3 minutes, let's turn over to mission control audio and follow the remainder of the count.
Flo, this is flight on mission. Flo, please disable the power pack HVAC and confirm.
PMS, this is LD on mission call.
Go ahead.
I confirm you go for auto sequence start at T-minus 2 minutes.
Copy that. Auto sequence locked.
Avionics flight mission cord.
Flight avionic.
Please confirm all AV vets have been switched to internal power.
Vehicles on internal power.
RCO flight mission.
Go ahead.
Confirm ground power is disabled on all 3 stages.
Power's down.
Okay, all stations, this is flight on mission cord. The vehicle is now on internal power.
Pressing locks.
PLS flight mission code.
Pressing Caro.
Please disable the anti-geysering and confirm. Stage 1 flight mission.
Go flight.
Confirm stage 1 is pressed.
Stage 1 pressed.
Stage 2, same to you.
Stage 2 is pressed.
Fast blow wedges on.
Commanding deluge on.
Can confirm deluge on.
Readying GNC systems. Re-readying engines.
Ten, 9, 8, 7, 6, 5, 4, 3, 2.
Stage 1 propulsion is nominal.
Beginning pitch over.
As you just saw, we have had successful liftoff of the
IMD tracking
R3D2
downrange.
mission on Electron. Coming up soon, Electron will go through a series of mission milestones in quick succession, including main engine cutoff, or MECO, where the 9 Rutherford engines on Electron's first stage will shut down. Shortly after this, we'll see Stage 1 separation, followed by ignition of the vacuum-optimized Rutherford engine on Electron's second stage. Following second stage ignition, Electron's fairing will separate, revealing the payload in preparation for deployment approximately 50 minutes from now.
Next Q.
One minute remaining.
Stage 1 propulsion still nominal.
AOS Chatham Station.
Power pack CO2 successful. Engines throttle down, 20 seconds remaining. Entering burnout detect mode.
Stage 1 MECO.
Stage suppression succeeded. Ignition on stage 2, propulsion is nominal.
Right down the center line.
Fairing jettison.
And there you have it. Confirmation that Electron's main engines have shut down as planned. We've had Stage 1 separation, and the Stage 2 engine has successfully ignited. Electron is now carrying on to orbit.
Speed is 3 kilometers per second. Altitude is 150 kilometers.
Stage 2 propulsion still nominal.
Getting throttle down. Guidance is nominal.
One of the unique features about Electron is its Rutherford engine. These brushless DC motor engines are powered by lithium polymer batteries. In a few moments, we'll be performing a battery hot swap where we switch from 2 depleted batteries to a third fully charged battery. Shortly, we'll see the depleted batteries jettisoned to allow for a more efficient flight to orbit.
Vehicles transited successfully to safe gate.
HV battery hot swap. HV battery eject.
"100 seconds remaining. "1 minute remaining.
Stage 2 propulsion still nominal. Entering stage 2 burnout detect mode.
"30 seconds remaining. "10 seconds. Successful transfer orbit.
Interstage separation.
All right, you heard the call. The kick stage has now separated from Electron's second stage. Approximately 40 minutes from now, the Curie engine on the kick stage will ignite and circularize to a 425-kilometer orbit for payload deployment. Because we won't be receiving video of today's payload deploy, this animation shows what the deployment of the R3D2 spacecraft will look like. Once the kick stage reaches a precisely planned point in orbit, the R3D2 payload will separate from the kick stage approximately 40 minutes from now. At this point, the mission will be complete. Here at Rocket Lab, we don't just go to orbit, we deploy satellites with exquisite accuracy thanks to this kick stage. The small but agile upper stage is equipped with cold gas thrusters that enable precision pointing. It means we can orient the kick stage to just the right position, then deploy our customer satellites to exactly the right orbit. So with that, we're going to end today's webcast. Thank you to DARPA and our mission partners for choosing to launch on Electron. Here at Rocket Lab, we're opening access to space to improve life on Earth, and today's mission to test new space technologies is another successful step in achieving that goal. Stay tuned to Rocket Lab's social media channels for mission highlights from today's launch, as well as confirmation of payload deployment. So wherever you are in the world, thank you for joining us today for Electron's launch. We hope you'll join us again in April for our next launch. This is Mission Control Auckland, signing off.